All right, we're on to 3.2D lesson. And here are the notes, and we're going to go through an example of how to solve this. So first off, when you have a least squares regression line, let's just talk about how to calculate that. Now, if you were to do it by hand, we know how to do it on a calculator. But doing it by hand, we have a y-intercept, and we have the slope located there. So we can call this b sub 0 and b sub 1. Now, to calculate the slope, one thing we can use is this. So if you're given the r value, so the coefficient, and you multiply that by the standard deviation of the y values over the standard deviation of the x values, so those are both the standard deviation of the y and standard deviation x, that will give you your slope. Using that slope, you can actually plug the value in there. Okay, so if you had this, you can then calculate your y-intercept, okay, by actually subtracting this to their side. And what we know is that actually, if you're looking for that one point, because you need a slope and a point to figure out an equation of a line, our point is actually the averages of our x values, okay, explanatory variable, and the average of our y values. That is given our point. So the point on a least squares regression line right here, okay, is actually the average of the x's and average of the y's. That's our initial point. And then from there, we can calculate what our slope is by taking our r value and then multiplying that by the standard deviation of the y's over the standard deviation of the x's. Pretty cool. Now, there are some things that affect this, okay, that affect this. And so what we know is that outliers outside of the pattern, all right, have very large residuals, okay, very large residuals. They actually will then decrease, okay, these outliers that are outside of the pattern, okay, that create a large residual. So if we had like one right here, okay, that will actually decrease our R value, okay, that will decrease, all right, our R value, makes the decrease of our R, and also decrease of R squared. It will increase the S value. It will increase the S value. So if you have a large outlier outside of the pattern, increase the S value, decrease the R value, and that's what we know. High leverage points, very large or very small X values, okay? So if we have these way over here, these essentially, these very, very large or very small values way on the outside here are leverage points. They actually will bring up and down the slope depending on what we have, okay, depending on what we have. If they are on the line, okay, they will actually create like a seesaw value and go up and down. Influential points caused by change in slope, y-intercept, or r, those are influential points. So causes big changes in the slope. So for example, points that are very high leverage, so way out here, like if I put one way out here, what this will probably do is seesaw this down. Okay, so it'll decrease our slope or make it flatter, increase our y-intercept, and also depending on how close it is to the pattern, may increase, well, will potentially increase or decrease that. Okay. Okay, so we have that. All right. What we know then is how can we use these different things. So from here, let's go to example number 1. So let's say we have a scatter plot that shows the payroll in millions of dollars and the number of wins of Major League Baseball players. And so what we have right here, the points highlighted in red represent Los Angeles Dodgers. So this is the Dodgers. I'll just call it D. All right, far right, and the Cleveland Indians in the upper left. Okay, upper left. And we have that right there. Those are nuts. This is the Indians. I'll call that I. Okay. Now, from these, describe the influence the point representing the Los Angeles Dodgers has on the equation of the least squares regression line. Explain your reasoning. So what is going to happen to this equation? Well, because this is far out and is below this, all right, what will probably happen is wherever the mean, all right, X and Y is, wherever that leverage point is for the seesaw, it's probably going to drive, okay, the slope down, okay, slope is going to decrease, and y-intercept, because this will go down, this has to go up, and so the y-intercept will increase. increase because point is below or is below least squares regression line. Okay, is below and far out. Far out. All right. Have point is below and far out least squares regression line. There we go. Yeah. Now that's why the slope is going to decrease and the y value will increase. Now describe what influential point representing the Cleveland Indians, so now we're going to look at the Indians, has in the standard deviation of the residuals and R squared value. Now, because this point is fairly outside, okay, the Indians value, okay, the Indians point is outside the pattern, for other points in the payroll. All right, what will this do? Payroll, the point will probably increase the standard deviation of the residuals. They'll probably increase that value. And will bring the R squared value smaller, and probably just decrease the R squared value, and will decrease R squared value. All right, percent variation will become less, okay, by that, and that's what we know. So the R squared value will become smaller. That's what we also know. So let's say we collect the data from the sample of 15 high school students, investigate the relation between foot length, okay, foot length and height. The mean and standard deviation of foot length is here. So here is the mean of the x values and the standard deviation, and the mean standard deviation of the heights. All right, right there. There should probably be a line over the top of that one, not below it, but that's okay. Correlation between the foot length and height is the R is that. Find the least squares regression line. Well, this is where we're going to use our little equation. What do we know? Well, we know that y prime is going to equal b sub 0 plus b1 times x. We can find b1 first. How do we find b1? We're going to take our r value and multiply that by s sub y over s sub x. And so what is that going to entail? Well, we're going to take our 0.697 and then multiply that by 10.69 divided by 2.71. And so if we go over our calculator, all right, and turn that on, we can take 0.697 times 10.69 and divide that by 2.71. And that will give us our slope. And so our slope is roughly going to equal 2.749. And we'll just go with that. Now, in order to figure out our y-intercept, we have to figure that one out. So we find, all right, whatever this value is right here, and we're going to take one of our points. So what we know is we take our 171.43, because that's a point on the predicted value. So we take that one, all right, and so that's going to be our mean of our y's, and we're going to subtract our slope, 2.749, this one over here, times, all right, whatever our average of our x's are, foot lengths, And so we have 24.76. So plug that in there. And that will equal, my friends, our y-intercept. And so we go to our calculator, say 171.43. And we're going to subtract that from 2.749 times 24.76. And bada bing, bada boom, we find out that our y-intercept is 103.36. And so we have our equation of 103.36. And maybe run to 5 right there. And we'll add that to our slope, which is 2.749 times x. And that, my friends, is our least squares regression line. All right, so there we go. We're talking about how does the least squares regression line talk about leverage points and outside the point patterns and how that affects standard deviation and our squared values, and also how to use these various things, how to identify a point on this to create a least squares regression line. I hope this helps you out, and good luck with all the rest of the problems.